Hello everybody and welcome to my project for data visualization and exploration. Today I'm kind of going to be going over a little bit about this project and showing off the visualizations for it. So first off, a little bit about my project. It has to do with recall data. So say for example we have this first data set here and it has information such as the product that was recalled, the remedy type, so it can be such as like a repair. It can also be a refund, the number of units and stuff like that, and the actual place it was imported from, so that's very important. And one of the other data sets we have is specifically this one right here, and it is for cars starting from the year 1969, I believe it was. And it pretty much goes over the manufacturer of the specific car part, the make and the model of the car, what year it was recalled, and kind of like a description about why it was recalled. And then the last data set we have is going to be this one right here, and this is from an Australian data set dealing with medical devices and why they were recalled. So it has the type of product. It can be a medical device, it can be a biological device. It also has the recall action too. Say for example, was it used in a hospital? Was it used for consumers? Was it used for retail and information such as that? And so with this project, it was done in Python. And if we take a look right here real quick, we can kind of see I've created quite a bit of functions to be able to take this data and be able to split it and clean it as needed. Say for example, there were many instances in the data set, such as, let me find it here, like this one right here. If we scroll on over, in this column right here, manufactured in, we have various countries that it was imported from. Let me see if I could find an example right here. Here's an example right here. Sometimes the data would have two of them, such as Vietnam and China. But for our purposes, we wanted to count them as individual units. So we went ahead and created a couple functions to be able to clear through this data and be able to classify them as such. And then there was also a number of instances, such as the remedy type. Sometimes it would also be a similar way, how it would have a refund and repair option too, so not just one of the instances. So we created a couple functions to be able to go through this data set to be able to work on that as well. And then for the other data sets, some methods were created, such as this one right here, to be able to go through that, to be able to see through this column right here, MFG text, which stands for manufacturer text, which is the specific manufacturer that created this car part that was recalled. So that way we kind of create a couple functions to go through there and be able to work on them. And then specifically for the Australian data set, some similar methods were done in correct data set. This one right here. To be able to filter them, such as the recall action level right here, we were able to classify them as either the hospital, retail, or consumer, and just pretty much created some methods to be able to classify these as such. And then if we go to the actual setup, not the setup utility, the actual dashboard application, as you can see here, we go and start off by reading in the data from all three data sets, and then we go ahead and call the specific methods to be able to subset our data and how we like it. Now, one of the most important things here is that I did use Python Dash. It is a dashboard tool to be able to help create dashboards with minimal HTML code. And say, for example, here, we use a little bit of HTML code to create some headers, some information about the paragraphs, and then we actually add in the charts, such as this DCC graph component right here. And we'll create a bar chart, and we'll be able to see that here soon. And then along with this, instead of just having kind of like a blank canvas, we also decided to make a style CSS file. So that way it kind of holds all the information, so that way we don't have to manually go through and adjust everything we need. We can just use the included CSS file to be able to adjust some things as needed. Let's go ahead and take a look at the dashboard. Alrighty, so we have the dashboard right here, and you can kind of see what I mean about we created the header. We also created the headers for the specific sections too. And as we scroll down, it's broken down into the 3 data sets, so that way you can be able to see them a lot easier. And we have the car one here as well. Let's go and start off with the first data set here. One of the first things that we did see when we were working on the project was specifically that China has the largest number of instances, with a total number of 17,038 instances. And we have a couple more countries such as Taiwan right here, Mexico, and Vietnam, with all a high number of instances. And one of the best parts about Python Dash is it uses the Plotly library, so we can be able to make this data set interactive. So what it means by interactive is so we can drag here. I can be able to subset this data right here. If it will work for me. We'll come back to that one real quick. But yep, the next one we have right here is the recall type. So this one right here is kind of the one we was mentioning earlier, how it can either be a refund, it can be a replace, it can be a repair, it can be new instructions printed on there, dispose of the product, no remedy available for the product, and even a new label for it too. So like I was mentioning, a good thing about Python Dash is that we can be able to select these. So say for example, if we don't want to look at the refund, we can turn that off and we can see that replace is now the biggest one. And then we can also kind of close these lower ones too, such as the label, no remedy available. And that we can see like the graph doesn't really change because of the such low instances. And then we can also be able to double tap on it. Actually, I think it's this one. And then we can be able to turn them on and off as needed. And one of the biggest things I did see here is that refunds do take up the majority of this data set. And then we also have replace next is going to be the next biggest with 537 instances. And then repair is going to be the third biggest with 312 instances. And then we have the new instructions is the very lowest right there, and those take up not even 4% of the data set, so very small number of instances. But I decided to include them just for more information. And then we can go ahead and move on to the next data set, the product recall analysis for Australia. And remember, this is one specifically dealing with the medical devices. And so right here, it's kind of broken down into the type of recall that was initiated. Now, the biggest distinction between the product defect correction, recall for product correction right here, is that the hazard alert and product defect alert, there we go, it's actually working now. I was wondering what I was doing. But yeah, specifically these two instances right here are alerts rather than actual recalls. So with the alerts, it's kind of alerting the public that, hey, there is a potential problem with this, but no need to recall the product. And so that's the biggest difference between those two specific groups right there. And you can kind of see that there are more actual product recalls and corrections than there are alerts for them. And we can see that there is the highest number of recalls here, which is 2,340 instances. And then we can move over here to recall for product correction at 2,031 instances. And then for an actual defect correction is going to be 1686. Now for this column right here, product defect correction, it simply means that the product has a defect and it needed to be either fixed or repaired. And then for product correction, it can usually mean something like there is a mislabel on there, it needs to be updated as such, and then recall is the actual full product pulled off the shelf. And then we can scroll a little bit more down here on our dashboard. And then this is kind of like how I was mentioning the specific use cases for it. As we can see, the hospital use cases take up the majority of the data set, with 86.6%. And then we have retail with a little bit lower at 591 instances, or 7.46% of the dataset. And then we can go ahead and turn off hospital to kind of see the dataset a little bit better. And as we can see, wholesale medical products only take up a small percentage of the actual dataset. And then this very tiny sliver right here, sponsor, has only 3 instances in the dataset. And I was just theory crafting on why the hospital medical devices have a higher occurrence. I believe I was leaning more towards hospital products may have a higher standard that they have to meet, and if they don't meet that, they classify into the recall category. And let's isolate a few of these. As we can see, we can really tell that the sponsor and the wholesale products really don't take too much of the data set. Even whenever we remove the hospital and the retail from the equation, it still takes up barely a fraction of the data set. And then we can go ahead and move down here a little bit more. And then here I was mentioning how there's 3 distinct categories. There's the medical device section, the medicine section, and then the biological section. And as we can see here, medical devices take up a majority of the data set compared to the other 2 groups being medicine and biological, where medical devices take up 90.5% of the data set, medicine takes up 7.9%, and then biological takes up 1.6% of the data set. Now it's interesting to note with the medical devices here how it takes up a majority of the data set, similar to the figure above, how hospital devices took up a majority of the data set. I believe these two go hand in hand, meaning that a lot of the hospital, or a lot of the use cases that was for the hospital must be medical devices, and the smaller ones such as the retail and consumer most likely might be the medicine right here. And then we can be able to turn off the medical devices so we can see the 2 other groups a little bit better. And as we can see, the medicine section does take up quite a bigger majority than it does compared to the biological, since the biological only has 105 instances in the dataset. And now we move on to the car recall analysis. Again, this information is for specific car parts recalled, and it starts since 1969 and includes the various information about the recall types and the manufacturer. And this is going to be a little bit of a time series data set. So say for example it starts here, and then it kind of moves up into the last piece, 2017, and then 2018 starts right there. And then I was noticing it kind of follows a little bit of a pattern, how beginning here in the late 60s it starts to increase the number of car recalls, and then we actually start to decrease as we start to get to the 80s, but then as we start to get into the year of like 1993, or no, I'm sorry, 1983, 1984, it actually starts increasing to where it reaches its all-time peak at about 2007 with 5,062 number of recalls in that year, and then it gradually starts to go lower as time goes on. So it kind of follows a specific nature and pattern, and I did note that in the report too. And to be able to get a better view, we can be able to isolate them, so let's drag here. We can be able to see over the years that there is a small pattern going up right here. It did dip a little bit in 1976, and then it went up a little bit in 1978, and then it starts to go down a little bit more, and then we can auto scale back over here. And then let's go ahead and look over here and see when it actually started to go back up. And as we can see, beginning in 1986, it started to go up quite a bit more. There were a couple of years, such as 1991 here, and 1992, where it did dip a little bit from the previous year of 1990. But as we get into 1993, the number does increase. And if we start to isolate them here, we can see it does start to go up a little bit But then we do have a couple number of instances, such as 2002 right here, where it did decrease from the previous year of 2001. But then starting in 2003, and a couple years after that, it does start to go up a little bit. As previously mentioned, starting in 2007, they actually do start to decrease the number of recalls for cars for that year. And then this section right here actually has to do with which specific entity recalled the car product. So say for example the MFR right here, which that stands for the manufacturer recalled the product. The ODI is the Office of Driver Information, I believe that was. And OVSC stands for the Office of Vehicle Safety Commission. And as we can see, it does show that the manufacturer is the higher number of instances in the data set, which would mean it takes up the bigger majority here. And then as we move over, the ODI only takes up a smaller percentage. And then the Office of Vehicle Service Correction actually takes up 6.72% of the data set here. And we can be able to isolate them as such. And as we can see, the ODI does take up a bigger majority than the OVSC right here. And one of the interesting things I was looking at in the data set is just how many parts the manufacturer decided to recall. Now remember, the manufacturer column right here does include all of the manufacturers that are going to be shown a little bit later on our list right here. But it's good to know that the manufacturers are actually finding problems with their car parts and actually recalling them as such. But then there does exist instances right here, such as with the ODI and the OVSC, where they decided to actually recall them themselves and initiate the recall. So this visualization right here has to do with which specific entity decided to recall the product. And then this one right here is a little bit of a more interesting graph. One of the most important things about this one is that it is sorted by lowest to greatest. So we have the lowest number right here of Subaru, and then we have the bigger one over here with General Motors. One of the more important things with this data set is that it has been filtered with candidates above 600 instances. So if there was a manufacturer that had less than 600 instances, they were not included on this visualization, since there are many small manufacturers on the data set that only had like 3 or 4 instances, so we didn't decide to include them on this data set. Now, as we can see here, we can kind of zoom in a little bit more here. The General Motors Company, the Ford Motor Company, and Chrysler all make up the top 3 biggest number of instances, with General Motors having over a staggering 10,000 number of instances, the Ford Motor Company having 7,300 about, and then Chrysler having 6,000 number of instances, making them the top 3 biggest on our list here. And then we also have a couple other smaller ones here, such as Mack Trucks, recalling a certain number of 1, PACCAR Incorporated. We also have some other big name ones, such as Volvo right here. We also have the Toyota Motor Company. We also have BMW that's also up on the list here. But at the very end of the list here, we actually have a couple important ones over here. So let's go ahead and isolate these real quick. We have the lowest number on our graph right here with Subaru of America. And we also have another one right here, Volvo car. But this is specifically for the United States. If we go back out, we can see the Volvo one right here. This is specifically for North America with 1,993 instances. But if we go back over here, we can see there's another big name manufacturer right here with Mitsubishi Motors America having 673 instances. And then if we go back out right here, yes, as previously mentioned, this graph does show sorted least to greatest, so we did have General Motors over here. And then so with the data sets right here, let's kind of go over them a little bit more. Let's go back up to this one real quick. Let's go back out. I'm trying to get this one to work right here. trying to get this one to isolate so we can see it a little bit better, but it looks like it's having a little trouble here. Let's go back over here to the dashboard. Let's go and open up another one real quick. And a really good thing about this is that all of it is hosted locally on the machine, so whenever you actually run the Python script, it creates a specific website for you to visit. And once you visit the website, you can be able to view the dashboard such as this. So yeah, let's go back over here and let's see about these small instances over here since we didn't get to work with them earlier. There we go. Alrighty, we can see here there are a couple small instances such as California right here. We're calling about one product, it looks like, if I can hover over it correctly. Yep, California had about one. We also have other small countries such as Slovakia, only we're calling one. England only we're calling one. Then we have Nepal here with about 2 instances. And then we can zoom back out. And then we can move back over here. We can filter these, and these have a little bit more number of instances, such as we have France right here with 13 instances. Italy has about 21 instances. Turkey has about 9. Peru has about 12 that has been recalled from this data set. And then we can move a little bit more over towards here and get a better view. And as we can see, countries such as Mexico, Vietnam, Bangladesh, they all have a high number of instances. But specifically with China right here, they do have the biggest number of recall instances. And it is important to note that this specific recall type breakdown was specific to China. And so say for example, like the number of refunds total to about 882. And I just wanted to make that clear that this visualization right here is specifically for China right there, rather than like whole encompassing for the whole data set. So yeah, that's pretty much the project. It's going to be uploaded to the GitHub, so if you want to clone it and go ahead and install the dependencies and go ahead and run this too and have a look too, it's going to be perfectly fine. Alrighty, that's all it's going to be for me today. Thank you guys so much. Goodbye.